I'm Rajiv. I'm a chemistry graduate from Oxford University, and I've done a lot of tutoring of maths, sciences, and general entrance exam help over the last 10 or so years. Today, I thought I'd show you a new way of solving quadratic equations, which could be significantly quicker than just using the quadratic formula. So here I've got a general quadratic equation, ax squared plus bx plus c, and here's the quadratic formula. Now this is a guaranteed way of solving this equation. It will always work. However, it's quite big, can be quite time consuming, and it can be easy to make mistakes around here. So I'm going to be showing you a method where you can have a quick look at this equation and decide if you can solve it significantly quicker. So let's take an example problem. X squared plus 7x minus 30 equals 0. Now here I've just shown how you'd solve this with the quadratic formula. You'd have to do 7 squared minus 120, square root that, plus or minus the minus 7, and divide by 2. Easy to make mistakes and takes quite a lot of time. So I'm going to show you a factorizing method, where you'll be able to very quickly get to the answer. And I'll do this first by going through a slightly easier problem. So here we have x squared plus 5x plus 6 equals 0. And I'm going to say I want to try and get this into the form x plus a, x plus b equals 0. I want to do this because if two numbers multiply to be 0, then one of them has to be 0, which means either x plus a equals 0 or x plus b equals 0. And if x plus a equals 0, x has to be minus a. And similarly here, x has to be equal minus b. So let's just have a bit more of a look at this formulation. We're saying that x plus a, x plus b has to equal 0. So if I just multiply this out, x squared plus ax plus bx plus ab equals 0, and then I just group together my x terms here, I end up with this. So now let's compare that to our original question. X squared plus a plus bx plus ab equals 0, and x squared plus 5x plus 6 equals 0. Now if we compare our x terms, we can see that a plus b has to equal 5, and if we compare our non-x terms, ab has to equal 6. So now, instead of the quadratic equation, we just have these very two simple equations to solve. ab equals 6, and a plus b equals 5. And hopefully we can quickly see that the only two numbers that will work here are 3 and 2. So 3 times 2 is 6, 3 plus 2 is 5. So now let's put this back into our original proposal. We've said a equals 3 and b equals 2. This is what we were trying to get to. So if we put the a and b into there, we get x plus 3, x plus 2 equals 0, which means x has to equal minus 3 or minus 2. Now actually, I've gone into quite a lot of detail on how to get to this answer from that original question. But now I'll just tell you how, once you're used to this method, the steps you would take. You'd be given this question, and you'd quickly say, right, what two numbers can multiply together to give 6? And because this is a positive sign, and I'll come back to this later, what two numbers add together to give 5? Those two numbers are going to be 3 and 2, and we get to our solution. So now let's look at how we can use this method of solving our original problem. We're looking at x squared plus 7x minus 30 equals 0. So now let's ignore the signs for a second. We're going to look at two numbers that multiply together to give 30, and because this is negative, before we were looking at two numbers that added together to give this, but now let's just think about two numbers that can subtract to give this. So if I have a look at my 30, the pairs that work are 1 and 30, 3 and 10, and 5 and 6. I have a quick look at these and say, do any of them subtract to give 7? Yes, 3 and 10. Okay, great, so we know our answers are going to have something to do with 3 and 10. Now let's make sure we've got our signs right. The original hypothesis has to say that AB equals minus 30 and A plus B equals 7. So let's just make sure we get our signs the right way around. if we try a equals plus 10 and b equals minus 3, because we know one of them has to be positive, one has to be negative, because you're multiplying two numbers to give a negative number, then we can see 10 minus 3 is 7, and 10 times minus 3 is minus 30. We put all this back together, and we have our a and b values here, we have our x plus a, x plus b format here. Solve for this, x plus 10 equals 0, so x equals minus 10, or x minus 3 equals 0, so x equals 3. I'll do a couple more examples, so hopefully this really settles in and starts to become second nature. X squared minus 2x minus 48 equals 0. Again, let's ignore the signs for a second and just say we're looking at two numbers that multiply together to give 48. Now, because this is a negative sign, we're going to be looking at two numbers that have a difference of 2. We'll look at our pairs again, which two numbers multiply to give 48. We can see here the pair that's going to work is 6 and 8, because they have a difference of 2. So all we have to do now is make sure we get our signs the right way round, and we can use 8 and minus 6, or minus 8 and 6. Because we're looking for a plus b equals minus 2, we'll use minus 8 and plus 6, put those into our formula, and we get x equals 8 or minus 6. Right, so finally I'll show you an example where this could really save you some time, rather than using the quadratic equation or completing the square if you've come across that method. Say you were given this. If you were using the quadratic equation, you'd end up with a 17 squared, a 4 times 16, a square root of all of that, and very easy to make mistakes. However, in this method, we're going to just look for two numbers that could multiply together to give 16, and because this is a plus, add together to give 17. Again, hopefully we can get to the answer that those two numbers are going to be 16 and 1. And now this time we don't need to worry about signs, because we can just use the positive of each, put them into this format, and we very quickly get to x equals minus 1 or minus 16. Now it's worth saying this method won't work in all cases, because sometimes you'll get some quite unfriendly numbers going here. And also, if you've got something here as the x squared coefficient, this can get a bit more tricky. However, if you've got a 1 here, it's worth just taking a few seconds to glance at this number, and the sign here, and decide, can I use this method? It might save you a few crucial minutes in the exam.